Hi everybody, hope you're doing well. This video here will talk about the angle addition formulas for sine, cosine, and tangent. And so angle addition, adding up angles, or actually we include angle subtraction formulas along with this group. But for example, I'm talking about things like the sine of A plus B. Now if you happen to already know what A and B are, then there's no need for an angle addition formula. Of course, you just add them up and take the sine or the cosine or whatever you need to do. But these angle addition formulas are more for expressing, in general, the exact trigonometric functions for sums or differences of numbers. Angles maybe, or maybe just real numbers, who knows. So they are very useful formulas, and they have another purpose as well that we will spend a little bit more time on in this video. But anyway, here's the first formula here. Sine of A plus B equals sine A cosine B plus cosine A sine B. Notice we keep the A and the B in the same order, and sine, cosine, cosine, sine. That's the order that the functions lay out in. The subtraction formula for sine is exactly the same setup. It's just that now we're using minus signs instead of plus signs. Sine, cosine, cosine, sine. Keep A and B in the same order. So for cosine, it's a similar kind of situation. The cosine of A plus B is cosine A cosine B minus sine A sine B, so cosine, cosine, sine, sine. Keep A and B in the same order, just for convenience, of course. And the subtraction formula for cosine looks pretty much the same as the addition formula, just with the flipped pluses and minus. Notice one thing here. When we are talking about the cosine angle addition or subtraction formulas, we have to make sure that we switch the sign. If we're adding two angles together, we subtract in the expansion of that. Or if we're subtracting two angles, we add in the expansion. Okay? So that's it for sine and cosine. We did talk about kind of a fun little way to memorize these formulas, but that's going to be up to you. Sine, cosine, cosine, sine. Cosine, cosine, sine, sine. It's kind of nice. Let's move on to tangent. So the tangent angle addition formulas, well, kind of the bad news there is that it's a fraction. But anyway, this is what it looks like. Tan of A plus tan of B over 1 minus tan A times tan B. So notice that when we are adding angles together, it's a plus on top, and it's a minus on the bottom. So it's the sum over the difference, you could say. And when we take tangent of A minus B, that is, again, in the same setup, but just now it's a minus on top and a plus on the bottom. Okay? So these formulas here are going to be part of your repertoire of things to use as we progress our study of trigonometry. And as I said earlier, these angle addition formulas give us a way to express the exact trigonometric functions for sums and differences of angles, or just of numbers in general. But there's another, kind of a more practical purpose, and that's what we're going to spend the rest of this video on. All right, a couple of examples on how to use this. This is kind of an interesting thing. The angle addition formulas also give us a way to express exactly, give exact expressions for another whole group of angles. You know, we've got the unit circle there for us. We got 30, 45, 60, 120, 240, etc., etc. And we can get the exact sine or cosine or tangent of all those angles. You know, tangent of 120 is negative root 3. Sine of 30 is 1/2. All these exact expressions for those angles. So on the unit circle, we have these angles that we can get exact expressions for. But with the angle addition formulas, we have a way to get exact expressions for a whole other group of numbers, such as 15 degrees, or 75 degrees, or 105, 165, and then there's several others, by using sums or differences of these angles right here, 30 and 45, 45 and 60, etc. We can get these other exact expressions for more angles. Okay, so let's try that. Our first example here, we're going to find the exact expression for the cosine of 75 degrees. Okay, so cosine of 75, well, that's not on the unit circle, of course, but I can rewrite 75 as the sum of 45 and 30, right? 45 and 30 are on the unit circle. Now, you might think, when you start off this, that you can write this cosine of 75 degrees as 70 plus 5, 100 minus 25, or 78 minus 3 for that matter. There's all kinds of pairs of numbers that you can come up with that by adding or subtracting equal 75 degrees. But we don't want to use ones unless they are on the unit circle. Okay? So 45 and 30 work, and there are other pairs that work also. But so let's use 45 and 30, and when we expand, so we're not going to use those other ones there. When we expand out the angle sum there for cosine, cosine 45 times cosine 30 minus sine 45 times sine 30, all right? That's how it expands out. And this is pretty easy now because we know what all of these numbers are. We know that the cosine of 45 is root 2 over 2, and the cosine of 30 is root 3 over 2. We know that the sine of 45 is root 2 over 2, and the sine of 30 is 1/2. So all we have to do is multiply that stuff together, root 6 over 4 minus root 2 over 4, and that's our sum right there. That is our exact expression of cosine of 75 degrees. So it's not so bad. Let's try another one that's maybe a little bit harder, using a radian angle this time, 11 pi over 12. Well, if you think about this for a second, you can come up with two numbers that add up to 11 pi over 12. And kind of an easy way to do it is to think about denominator 12 there. You could think 11 pi over 12 is the same thing as 8 pi over 12 plus 3 pi over 12. And 8 pi over 12 is 2 pi thirds. 3 pi over 12 is pi over 4. So you can write 11 pi over 12 as 2 pi thirds plus pi over 4. And now we can use our angle addition formula for tangent. All right, you set that up, you got tangent 2 pi thirds plus tangent pi over 4 over 1 minus tangent 2 pi thirds times tangent pi over 4. And now we'll take a look and we'll put all of those values. The tangent of 2 pi thirds is negative square root of 3. The tangent of pi over 4 is 1, so that's not so bad. And then so we substitute those numbers, negative root 3, in for tangent of 2 pi thirds. Notice the subtraction here. I'm subtracting, and I'm subtracting the negative, okay? That means positive. So when I simplify that out, I've got that. And you might be tempted to just leave the fraction like that, because it's pretty nice, actually. It's not such a bad fraction. It does have a radical in the denominator, but, you know, it's not so bad. However, when you go ahead and simplify this, that is, rationalize the denominator of this, by multiplying their fraction by the fancy form of 1 there, 1 minus root 3 over 1 minus root 3, actually something pretty nice happens, and it is worth the effort. When you go ahead and multiply this out, using the distributive property on top, you have 1 minus root 3 minus root 3 plus 3. When you multiply all those things out on the top, you might want to stop and think about that for a second. Make sure you understand how we got all of those. Of course, on the bottom of the fraction, you just have 1 minus 3. That's the beauty of using of multiplying by the conjugate there. And when you gather your like terms on the top, you get 4 minus 2 root 3 over negative 2, which is pretty nice the way that simplifies down to just negative 2 plus the square root of 3. So that's our tidy little answer for the tangent of 11 pi over 12. Okay, well, that's enough for the angle addition formulas. Hope you enjoyed that. Thanks for watching. Bye.